Dear students, let us continue our learning the course Data Structures and Applications. We are in the second session of the fourth topic of the module 5, Files and their organization. The topics covered under this session are basic file operations, file organizations and indexing. Myself, Dr. Suresh.d from the Department of Computer Science and Engineering of Canara Engineering College, Bantwal, Mangaluru. First, the basic file operations means what are all the operations we can perform on the files. In the last video, we learned what is a file and what is a directory over there. So, file is made up of records. So, now each record is made up of some basic entities over there. So, now when we go out in file, what are the different operations we can perform on those files? So, let me take an example of the student file. So, of your class, let us take within strength with the number of records will be total 62 records are there. Let us take the student file. So, now in this student file, let us assume that there are 62 records are there and each record is of a student. Let us take each record is of a single student. So, now what are the operations we can perform? The first operation is the creation of the file. So, now we have created the file. The next one, updation. So, now for the third semester, it is the university will allow us to have the diploma students can be entered to the direct third semester over there. So, now when the students will enter into the third semester, now we need to update the student file. Means we need to go for changing the content of the file. The changes can be either I may go for inserting in a new record to the file, or I may go for modifying the existing record of a student, or I may go for deleting the entry. So, let us if diploma students are there, so assume 3 diploma students will enter into the third semester, then I need to have 3 records I need to insert over there. And earlier in the first year, in the first semester, somebody has a CGPA of some 7.4. So, now in the next semester, you obtained some SGPA of 9. So, now his aggregate is to be added, his aggregate is to be changed now. So, now for the changing, his aggregate will be now, let us take it as the 8.2. That is, I need to modify his aggregate. I need to go for modifying the aggregate of that student. Means I may need to change the content. I may need to update the content. The next one, assume some student got detained. Now I need to delete his entry from that file. I need to delete the entry from that file. That is nothing but the deletion over there. So all these 3 operations together we call it as the updating the content of the file. The next one, retrieval of the file. If some external people or somebody comes and ask for your marks, suppose the placement department want to know your marks, aggregate marks, then I should be in a position to retrieve your marks and I should be able to display over there. Or I want the placement department want the details of all the students who have an CGPA of 8 and above. So, in that case, I should be in a position to extract your details and I need to present it. So, these things we call it as a retrieval. Here we are not changing anything. Instead, we are just accessing the content. We are just accessing the content of the file. The next one, the maintenance. In the maintenance, what happens? I may go for restructuring, means rearranging. I may go for rearranging the file content or reorganizing the file contents. I may go for rearranging the file contents or the reorganizing the file content for the better retrieval. That will be regarding the maintenance. These are the 4 basic operations what we perform on the file. They are creation of the file, updation of the file, retrieval of the file content, and the maintenance of the file. First, creating a file. A file is created by specifying its name and the mode. The mode will give us, in the last class we have seen the mode. The mode can be either you have the mode as the read mode, or you can go for the write mode. That is, we will tell the mode of the file. That is, while creating the file, we go for specifying the name of the file and the mode. Then the file is opened for the writing records that are read from the input device. Once all the records has been written into the file, then the file is closed. Now the file is ready for the future read or the write operation over there. Future read or the write operations, the file is ready once you filled your records. Fine. By the program that can be designed to use it in some way or the other way, we can use that file. This is how we create the file. That is, for creating the file, we give the name for the file and the mode will be given over there. Next one, updating the file. Updating a file means changing the content of a file to reflect a current picture of reality. A file can be updated in the following ways. First one, inserting a new record to the file. For example, if a new student joins the course, we need to add his record to the student file. Next one, deleting an existing record. For example, if a student quits a course in the middle of the session, his record has to be deleted from the student file. Then the next one, modifying an existing record. If the name of the student is spelled incorrectly, then correcting the name will be the modification of the existing record. Modification is not only meant for your misspelling over there. Instead, you may have upgraded a higher rank. You may have an additional capability over there. So all these things we need to add to your current, or we need to change the current. So all these things comes under your modifying the files. These are the three main operations we perform on the updations of the file. The first one is inserting the new items to the file, that is a new record to the file, deleting an existing record, and updating the existing record. Then the next operation, retrieving from the file. Here we are not updating anything, so instead we are just getting the contents of the file. It can be an individual record we may get, or in a summary we may get. That is nothing but retrieving from the file. It means extracting useful data from a given file. Information can be retrieved from a file either for an inquiry or for the report generation. An inquiry for some data retrieves low volume of data, while report generation may retrieve a large volume of data. So normally for the inquiries it will be done on 1 or 2 records. But when we need the records, there we go for the large volume of data is processed over there. Then the next one, maintaining the file. It involves restructuring or reorganizing the file to improve the performance of programs that access this file. That is, to speed up the accessing the file, we may go for maintaining the file. Restructuring a file keeps the file organization unchanged and helps only the structural aspects of the file. Example, changing the field width or adding or deleting the new fields to the record. That is nothing but the restructuring and reorganizing the file. These are the 4 main basic operations we perform: creating the file, updating the file, retrieving from the file, and maintaining a file. Next, file organization. File organization. Organization of the records means a logical arrangement of records in the file and not the physical layout of the file as stored on a storage medium. So it is a logical arrangement. Fine. There are 2 entities you can see over here. One is the logical arrangement, other is the physical layout. If you take up your hard disk, so if you take up your hard disk, the hard disk is made up of the magnetic disk. Hard disk is made up of the magnetic disk. So the cylindric magnetic disk will be there. That cylindric magnetic disk are placed one above the other. Fine. So each disk. Fine. So that will have the number of tracks over there. A central spindle will be there, and the disks are placed over there. But when we open this hard disk in our My Computer, so My Computer will have the access to your hard disk. There, this disk shape is not visible. Instead, you can see the contents as C, D, and the E. When I open my computer, I can see the contents in the My Computer hard disk contents as a C drive, D drive, E drive, and all. But actually it is not. It is the physical organization is different. This is our physical organization, but this is our logical organization. Fine. So actual storage will be physical, but when we present, it will be a logical one. When we present, it will be a logical one. Fine. So now the files are stored in the physical media, but shown as the logical entity. The files are stored in the physical media, that is your magnetic tape. It will be stored in the binary pattern, ones and the zeros. But for your people, it will be showed as a logical entities like A, B, C, or the numerals like that. Fine. This organization of the records is a logical entity. It is not a physical entity. It is not how we store in the disk. It is not that one. It is how we logically arrange the records in the file. How we logically arrange the records in the file so that the retrieval will be efficient. We can have the faster retrieval. That's what our need. For the faster retrieval, how logically how we are arranging that one. That is your file organization. Right? That is organization of records means the logical arrangement of records in the file and not the physical layout of the file as stored in on a storage media. File reorganization may involve changing the entire organization of the file. The following consideration should be kept in mind before selecting an appropriate file organization. First one, rapid access to one or more records. That is, the retrieval should be faster. That is, this is what the need of the day. Fine. So that is, we want an effective retrieval, efficient retrieval. Fine. Suppose you went to a bank. Assume you have an account in a Canara bank and you went to the bank with your ATM card over there and you insert your ATM card. Fine. And it should retrieve your database of how much balance you have in your account. If it takes longer time, assume, if it takes longer, some 30 minutes of time, do you even keep your ATM card with you or will you close your account and move to some other bank? That is, if the accessing time, if the retrieval time takes longer time, so we may go for changing the bank. What happens? The bank may lose its revenue. That's why what the people need, we need the rapid access. We should provide the rapid access. To provide that rapid access, for a bank, you are not the only customer. It has the millions of customers over there. In those millions of customers, it should retrieve your account details very fast. Within a fraction of a time, you need to get your account details over there. Means you can think on the complexity over there. How much rapid you want to read your data. Fine. That's the need of the file. That is, file organization should arrange your data of all the employees in such a way that it should rapidly retrieve your data. Next one. It should be easy of inserting, updating and deleting one or more records without disturbing the speed of the accessing record. If you withdraw your money from the account, that should be updated immediately without disturbing the speed of the accessing record. Next one. An efficient storage of records. It should be stored efficiently. Means if you put some amount to your account and your account is not updated, then what happens? You go and fight with the bank. That should not happen. That is, the storage should be an efficient one. Next one. It should use the redundancy to ensure data integrity. It won't lose. If there is something happens to that data center where the data is stored. But after after some time we should get our data back. If the bank server or the storage collapses, do you agree that your money will be lost? No one will agree to it. So that's why somewhere we should our data to be integrated, not to be altered. For that reason, we need the redundancy. Means in place of saving at the one place, we may go for redundant saving over there. A duplicate copy will be saved. Fine. So these are the need of the file organization. That is, what are all the needs? We need the faster access, that is rapid access, easy of inserting, updating and deleting without disturbing the speed of the accessing record, efficient storage of the record, and using the redundancy to ensure the data integrity. Next one. What are the different ways of the file organization? Then how many ways the files can be organized? The first and foremost, the simple storage mechanism, simple file organization mechanism is a sequential organization. So sequential, as the name itself indicates, sequential means one after the other. Sequential means one after the other. Fine. That is how your data will be stored in the attendance book. You might have seen how we store your data over there. First will be USN number. First USN number will be 1. Next USN number will be 2. Next USN number will be 3. So this type of storage will be in a sequential one. Suppose I want the USN number 27. So before 27 I need to look at from 1 to 26 I need to look. Such organization, that is where the data or your records are stored sequentially. First record is stored. Next second record is stored. Next third record is stored. Such an arrangement of data will be called as the sequential organization. A sequentially organized file stores the records in the order in which they were entered. Sequential files can be read only sequentially, starting from the first record in the file. Sequential file organization is the most basic way to organize a large collection of records in a file. If you can see the arrangement of the sequential record over there. First, record 0 is stored, record 1 is stored, record I is stored, record I plus 1 is stored. At the end, record n minus 2 and the record n minus 1 are stored. Right? Now to get the record number 10, I need to first read the record number 0 to 9. Record number 0 to 9 I should read to go to the record number 10. That type of organization is your sequential organization. The features of the sequential organizations. Records are written in the order in which they are entered. Records are read and written sequentially. Deletion or updation of one or more record calls for replacing the original file with a new file that contains the desired changes. Means for the updating the sequential file, not possible. You need to create a new file to there, while copying you need to do the necessary changes. Records have the same size and the same file formats. Records are stored on a key value pair. Generally used for report generation or the sequential reading. These are the basic format of the basic format for this file organization, sequential file. Right? That is, the elements will be stored one after the other, and we can't update that one directly. For updation, we need to copy it to another file, then there we need to update the contents. Advantages. These are simple and easy to handle. Next, no extra overheads. Next, sequential files can be stored on the magnetic disk and the magnetic tape, which are the cheapest memory storage components. Next, wherever we go for the batch oriented applications, these sequential files will fit better over there. Disadvantages. Records can be read only sequentially. Updation is not possible. Fine. Again, we need to have the sequential access. That is, to read the ith record, I must first read I minus 1 records. Only then I can go for the ith record. Second one, does not support the update operations. A new file is to be created and the original file has to be replaced with the new file name that contains the desired changes. Then these functions, these sequential file organization cannot fit into the interactive applications, the live applications. Wherever we have the live applications, these sequential files will not fit. Sequential files will not fit for the live applications or your interactive applications. Then which file format will fit? That we will discuss next. That is, sequential files are the basic form of the file organization, where the data or the records are stored sequentially, one after the other. And to access the ith record, I must first read the I-1 records. It won't support update. For updation, you need to copy it to a different file and you need to make the updations over there. And these organization will not fit into the interactive applications. Then why we need? That is a question always. Because these are used in the batch oriented applications. And these organization is mainly used for storage in the lower cost devices, where we need to have the backup and all. For those cases, so these sequential organization fit better over there. And the next one, relative file organization. So it is in the relative file organization. So what happens is, suppose we go with the record number over here. So for each record, I will keep the 100 bytes of storage. So record 0, it will be stored from the byte number 0 to 99. Next, record number 1 will stored from 100 to 199. Record number 2, record number 0, record number 1, record number 2 will stored from 200 to 299. In the same way, if we continue, fine. Suppose I want to fit my fifth record. From where it will start? What is the size of each record? 100 bytes. So that is, it will be accessed directly. Go to the memory address 500. You have your data. That is, it is from the address 500 to 599. So such an organization is the relative file organization. Such type of organization will be your relative file organizations. How it will be stored and retrieved? Fine. First, record number 0. Record store will be record 0. Record number 1, record 1. Record 2, I don't have a record 2, leave it blank. Record 3, I don't have, leave it blank. Record 4 will be stored at the location of 4. Like this, the elements will be stored. But when you go for accessing that one, I want to access the 6th record. How to access the 6th record? Multiply it by the 100. So now this will be the 600. This is the starting address of your record. So in place of this 0, let us assume that it is started at the address 2000. Then what happens? This starting address will be 2000. This address will be, this starting address is 2000. Last address is 2099. So this is 2100, 2199. This is 2200, 2299. So now I want to access the 5th record. So how to access the 5th record? It is not 500 now. It is 2500. What is this 2000? So 2000 has to be added to 500. What is this 2000? 2000 is the starting address from where it is beginning. Now to access the 6th record, I need to go to the address 600. How? What's with 600? 2000 is the starting address. From there, I need to take in a 600th byte. This is the starting address for the 6th record. Fine. The same mechanism is applied over here. Fine. That is, if the here in this case, all the records will be of fixed length, and we know the base address. That is the address from where your storage has begun of the file, and the length of the each record. Then the ith record will have the address as ith record. Let me take the 600, 6th record, and each record length is 100. So how it will have? First one, the base address. Base address is it's 2000 plus I minus 1 into the record length. I minus 1 is a 5. 5, that is your I minus 1. That is it is the index is starting from the 1, not the 0. So that's why for this now our index we have started from the 0. So 0 to 5. So now it is a 6 means when we start from 0, this will be the 5. So now it will be the 5 into 100. So it will be start from the address 2500. How it will happen, just look. Starting from 0 2000 to 2099 is your 0th record, but in your number convention this is your first record. Then next second record 2100 to 2199. So this is your second record, but for the convention it is the 2 we are using. Then next for the 3 2200 to 2299. In the same way, sixth record. The sixth record will be stored from 2500 to 2599. So how we can do this one? So this is 2000 first plus 6 minus 1, that is 5 into 100. How much will we get? 2500. That is the starting address. Fine. So this is how we access the contents. This is how we access the content. So in this case, consider the base address is 1000 and each record requires 20 bytes of storage. To access the fifth record, how it will be? 1000 plus 5 minus 1, that is 4. 1000 plus 4 into size of each record is 20. So how much it is? 4 into 20, 80. 80 plus 1000, 1080. This is the address from where your fifth record is there. Okay. So now the features. That is access. For accessing, we don't need to have the sequential. One by one is not needed. Directly we can go to that location by using the above formula what we have discussed. The features. It provides an efficient way to access the individual records. Record number specifies the location of the record relative to the beginning of the file. Records in a relative file are of fixed length. Relative files can be used for both random as well as a sequential access. Every location in the table either stores a record or it is marked as free. If that record place is unused, then it is marked as free, or else we are going to store our record, it will be stored over there. Fine. So this will be regarding your second organization. What is that second organization? That is your relative organization. The advantages. First one is easy of processing. If the relative record number of the record that has to be accessed is known, then the record can be accessed instantaneously by using the above formula in the previous one what we have discussed. Random access of records makes access to relative files faster. That is, we can access the records quickly. Allow deletions and updations in the same file. Provides random as well as a sequential access of records with low overhead. New records can be easily added in the free locations based on the relative record number of the record to be inserted. Well suited for the interactive applications. Disadvantages. Use of relative files is restricted to disk devices. But the major drawback, all the records should be of the fixed length. For these cases, we want all the records should be of a fixed length. A random length records, it is we can't have the relative organization is not possible. For random access of records, the relative record number must be known in advance. If we know the record in advance, record number in advance, only then we can go for the random access over there. Next, indexed sequential file organization. The indexed sequential file organization can be visualized as shown in the figure. So how it will be stored? First, the record numbers 1 to 9. Fine. Then next, the address in the 1, if I go, I have the address of the record. The address of the record is 765. This is it is connected. In place of directly storing, so what we will have? We will have the address of the record over here. So now what is the limitation of the, do we need the size limitation over here? No, that size limitation can be relaxed now. Each record can be of a fixed length or can be of a variable length. But it provides an efficient data retrieval. It provides an efficient data retrieval over there. Fine. So now let us go with the indexed sequential file. So sequential file. What is a sequential file? The elements or the data are stored one after the other. 1, 2, 3, 4, 5, like this we will store. So next. So now this is the arrangement of the sequential file. Now this sequential file, this sequence will make it as the index. Now for each index, we, instead of storing our record, earlier what we used to do, so we used to store our record directly. Now that record storage direct is relieved. That the direct record storage is relieved now. Instead what we will do, this record will have some address. Let the address of this record be 700. Now this 700 will be stored at this index 0. Fine. In the same way, second record will be somewhere in the address of 500 as you. This can be any address. This can be any physical address. 500. So now this 2 will have the address value as a 500. So now the 500 is this record. Right? That is in place of direct storing of the record. So what we will do, we will create the address, we will store the address of that record in that sequential file. So now what the sequential file will have, index sequential file, one will be the index is your record number, other is the address. If we go to that address, there we have our file. Then if you go to the features of this one, so it provides faster data retrieval, records can be of a fixed length, and the index table stores the address of all the records in the file. But the accessing is sequential. To access the 7th one, I need to access the first 6th. First one, record 1, record 2, record 3, record 4, record 5, record 6, then the record 7. To access the 7th one, I need to check sequentially, I need to check 1 to 6. Only then I can go for the record number 7. Fine. That is the sequential storage, but it gives us the fast data retrieval. Fine. The index table will store the address of the record in the file. The ith entry in the index table points to the ith record of the file. While the index table is read sequentially to find the address of the desired record. A direct access is made to the address of the specified record in order to access it randomly. Indexed sequential files perform well in situation where sequential file access as well as the random access or the need is made into the data. Advantages. The key improvement is that the indices are small and can be searched quickly, allowing the database to access only the records it needs. Next, supports applications that require both batch and the interactive processing. Next, records can be accessed sequentially as well as randomly. Next, updates the records in the same file. These are the advantages. Both sequentially searching for the index. But if you go at that index, the record number will have the random access. Fine. Next, disadvantages. Indexed sequential files can be stored only on the disk. Needs extra space and overhead to store the index. That is, again, storing the index is a overhead. Fine. It is a overhead over there. Handling these files is much more complicated than handling the sequential files. And it uses only the fixed length formats are used over there. So these are the file formats what we have seen. The first one is sequential access, relative access, and the indexed sequential access. Right? Then next, let us learn the indexing technique. Right? So indexing, what is indexing? What is the indexing? That is the question always. Fine. If we go at the VTU university, and if you tell your name, if I tell the name as suppose say some XYZ, it won't recognize this XYZ. What it recognizes? It recognizes only the USN. What that USN will be? First digit will give us the region. Region 1 for the Bangalore region, region 2 Belagavi region, region 3 and the region 4. For you people, it's in Canara Engineering College, so region 4. It comes under your Mysore region. The next one will be the, once we go to the region, first is the region, that is the first index is the region. Next, once we go to the 4, again in 4 in the Mysore region, we have some 80 colleges over there. For these colleges, the VTU has given the code. For you people, the code is a CB. That is our Canara college. The next one, once comes to the Canara Engineering College, again we have the 4 year of students. We have the 4 year of admissions. So let us take the recent year. Recent year admission is 2020. Previous one 19. Previous one 18. Previous one 17. These students are studying over here. For you people, it is 19. Again when we come to the 19. So in 19, we have the 4 branches. CS, IS, Mechanical and the EC. For you, it is CS. Once we come to the CS, again for the CS, the total intake for 1 year is 126. In that 126, your USA number is 89. Right? So now once you give this full sequence, what is the full sequence? 4CB 19 CS 089. Once you give this index to the VTU, it will give you the details. This technique will be your indexing technique. Why we need it? For the faster retrieval we need, and efficient usage we need. For the university, if you take up, there are lakhs of students who are joining. Then how to track yours? There may be some 500 students are there with the name XYZ. How to track yours? So that is the reason why the indexing is very important. Here for VTU, how many levels of index we are using? First is the region wise, level 1. Next is the college wise, level 2. Then the year of admission wise, level 3. Branch wise, level 4. And your student number, that is your register number wise, level 5. 5 levels of indexing we are using. Fine. So this is what the indexing is all about. Fine. So now let us learn this indexing in detail. Let us learn this concept of indexing in detail. Fine. First, the indexing techniques is based on the factors such as access time, access type, insertion time, deletion time, and the space overhead inward. There are 2 types of indexes. One is the ordered index, which that are sorted based on 1 or more key values. For you people, we use the ordered index. So what is that ordered index? So first we write the USN number 1, next the USN number 2, next the USN number 3. That is the ordered index. And the hash indices that are based on the values generated after applying the hash function. So we apply some functions to calculate the index value over there. Fine. So let us take the example of searching a name in your telephone directory. So how the names will be searched over there? That is, we will go, suppose name is Paramesh. How we will search? First we will go to the P. After P we will go to the A. After A we will go to the R. Fine. So this is your ordered index. Then the next one. So based on, suppose the number is a P Paramesh. So I apply some function. Suppose there are 26 alphabets are there. I will apply the function as mod 26. So now when I do this one, so it is a P mod 26. P character value, let me take it as 17. 17 mod 26, it will give me the 17. So go to the index value 17. So instead of going like this as the ordered index, we go? We apply some function. That function we call it the hash function. So that function will give us one index value. That function will give us one index value, and that index value we are going to use. That index value we are going to used. Fine. So that is the second mechanism, that is by using the hash indices. First, let us learn the first concept, ordered indices. Indices or the index are used to provide the fast random access to the records. An index of a file may be a primary index or it can be a secondary index. Primary index. For you people, the primary index is your USN. Primary index is your USN over there. In a sequentially ordered file, the index whose search key specifies the sequential order of the file is defined as a primary index. Next one, that is, suppose a record contains a students in the student file sequentially starting from the roll number 1 to 60. Now if I want to search any student by their roll number, then it is a primary index. Now, second one, suppose your parent comes to the college and they don't know your roll number, but what they know your name and the year in which you are studying. Fine. So in the primary index, what happens? The example is your VTU. So VTU uses your register number. USN number is used. USN number is your primary index. Suppose your parents comes to the college and they don't know your USN number. What they know? In which year you are studying and what is your name and the branch. So now we search depending on the other values. That will be the secondary index. That is, an index whose search key specifies the order different from the sequential order of the file is called the secondary index. That is, if the record of a student is searched by his name, then the name is a secondary index over there. Secondary indices are used to improve the performance of queries on non-primary keys. Next, dense and the sparse indices. So in a dense, first sparse. Sparse means for the we will write it as register number 1 to 60 will be there in the A section, and 60 to 120 will be there in the B section. This representation is your sparse. That is sparse index. In a sparse index, the index table stores the address of only some of the records in the file, which we call the key records in the file. And what is the advantage? Sparse indices are easy to fit in the main memory. In a sparse index to locate a record, first find the entry in the index table with the largest search key value, which is less than or equal to the key. Then you have to make the jump. Suppose I want to search for 65. Then what we will do? We will find the largest matching value. The largest matching value is 60. So now we will go to the register number. From 60 we keep on sequential search. Fine. Such arrangement is your sparse index. Dense index. In a dense index, we give the full details. We won't write it as 1 to 60. We write it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that we used to give. That is, in a dense index, the index table stores the address of every record in the file. Dense index would be more efficient to use than the sparse if you have that enough memory. If you have the enough memory, that is, if all the index, if you are able to fit in the memory, then the dense index will work fine. By looking at the dense index, it can be concluded directly whether a record exists in a file or not. That is the advantage. If you take up the college, and the college, if they keep the dense index, what happens? Total, assume there are some 2000 students are there. All the 2000 entry will be there in the table. Again, it's a tedious one. But if you have a sparse, that is, we give only the from 1 to 20, like that if we store, then that will be easy. That is, if you have enough space in the storage, then the dense index will fit better. If not, then the sparse index will fit better. Most of the cases, the sparse index will fit better into the main memory. For the dense index, we need the larger memory to be used. Now, let us look at the example over here. Fine. If you need to access the record number 40 in the previous case and this case, this is for the dense. Record number 40 is there in the table, you can directly go to the record number 40. But for the sparse index, what is the nearest match? 30. If you go to the 30, then from there you can go to keep on, it's a sequential. Get the next one. Next one is 40. Then you can jump. Fine. That is the sparse. This is the second one is the sparse index. First one is the dense index. Fine. So in the sparse index, the highest, the largest key match is taken, not exact. In the dense index, the exact match will be taken and continued. But in the sparse index, a largest match, that is the nearest match. I can't call now largest. It is the largest and nearest match will be taken, and we will check if we'll go to that one. From there we go for the sequentially matching. From there we go for the sequentially matching. That is for the indexed sequential match. Right. Then the next one, cylinder surface indexing. So as I told earlier, your magnetic disk, the disks are placed one above the other, and these disks are arranged in a cylindrical shape. Outermost cylinder, you can see. Again, it will be divided into cylinders wise. This is the next level of cylinder. Next level of cylinder. Innermost cylinder over there. That's why it is a cylindrical shape we used to write, if you remember. Whenever I need to write an hard disk, I will write like this. It is a cylindrical storage. Now it is not looking good. Cylindrical storage like this. Fine. That is each one is a disk over there. Each one is one disk. Each one is one disk. And that disk is divided into the number of tracks. And each track is divided into the number of cylinders over there. Number of that is number of sectors over there. That is divided into the tracks and the sectors. And one cylinder, if I take up one cylinder here, this is one cylinder. It may have multiple tracks. Track 1, track 2, track 3. Fine. So such an arrangement is your physically hard disk. That is a cylinder indexing. Surface indexing is a very simple technique used for the primary key index of the sequentially ordered file. The index file will have the two fields over there. That is the cylinder index and the surface index. There are multiple cylinders and each cylinder has the multiple surfaces. If the file needs M cylinders for storage, then the cylinder index will contain the M index over there. M entries will be there for the cylinder index. Next. When a record with a particular key value to be searched, then the following steps are followed. First, the cylinder index of the file is read into the memory. Second, the cylinder index is searched to determine which cylinder holds the desired record. For this, either the binary search technique can be used or the cylinder index can be made to store the array of pointers to the starting of the individual key values. And both of them will take up the log m time. After the cylinder index is searched, appropriate cylinder is determined. Then, depending on the cylinder, the surface index corresponding to the cylinder is then retrieved from the disk. Since the number of surfaces on a disk is very small, linear search can be used to determine the surface index of the record. Once the cylinder and the surface are determined, the corresponding track is read and the searched for record with the desired key. Hence, the total number of disk access is 3. First for accessing the cylinder index, second for accessing the surface index, the next will be your track index. 3 index values we are going to use. For cylinder index, surface and the track index. That is, if you take up the example I told, so this is this cylinder I want to use. First cylinder index, which that is, it is divided into n cylinders over there. In that cylinder, which surface I am going to use? In that surface, which track I am going to use? Friends, these are it is a 3 level over there. The total number of disk access is 3. First one is for the cylinder index, second one is for the surface index, and next one is for the track index. Then the next one, multi-level index. In the multi-level index, when we have a large database, let us take your computer database or the large database wherein that maintaining the index itself is the tedious one. For your college, if you take up, if I maintain your 2000 students over there, then that itself is a tedious one. In these cases, we go for the multi-level indexing. In the multi-level indexing, how the college will perform? First, we have a record of 4 departments. 1, 2, 3, and the 4. So this is our college. Then in the 4 departments, again 4 years will be there. First year, second year, third year, fourth year. That will be connected to your actual storage over here. So how to access? First, college. This is our college. CB. In the CB, I want to go for the CS. In the CS, I want to go for the second year. In the second year, I want to go for the section. Again, there are 2 are there. Again, I want to go for the section A and the B. Now in the B, this is from the year to here I have my data. So this type of indexing is the multi-level indexing. So where it is applicable, consider whenever we have a large volume, large files which contain millions of records. In those cases, simple indexing techniques will not be effective. In those situations, we go for the multi-level index. So here we have used the 2 level of indexing. So index level 1 and the index level 2. 2 level of indexing. And in the same way, we can go for a 3 level, 4 level, like that. We can go for the many level of indexing can be used. Such a mechanism we call that as the multi-level indexing. The next one, inverted index. The inverted indices or the inverted files are used in the document retrieval systems for the large textual databases. Why we need this one? So why we need that inverted means for the faster retrieval. For the whenever we have a textual database, text database is there, and you want to have a faster retrieval, in those cases we go for the inverted indexes. An inverted file reorganizes the structure of the existing data file in order to provide fast access to all records having one field falling within the set of limits. When a term or keyword specified in the inverted file is identified, the record number is given and the set of records corresponding to the search criteria is created. For each keyword, the inverted file contains an inverted list that stores a list of pointers to all occurrences of that term in the main text. So therefore, given a keyword, the addresses of all the documents contain that keyword as easily be located. There are 2 variants are there. The first one is a record level inverted index, other one is a word level inverted index. In the record level inverted file, it stores a list of references to documents for each word. Word level indexes, a fully inverted index or the inverted list, in addition to the previous list of references to document to each word contains the positions of each word within a document. Inside the documents where that word is repeating, that will be done with the word level of inverted index. Next, balanced tree indexes. So that is a B tree stands for your balanced tree indexes. So it is impractical to maintain the entire database in the memory. Fine. So that is I am not storing all my files in a single drive. How I am storing? First I have divided my hard disk into the partitions C, D, E and all. In the D, again I have divided into the college. Again in the college, I have divided into the classes which I am handling, 3rd semester and the 5th sem. In the 3rd sem, again I will go with the subject DSA. Fine. That is, I am forming a hierarchical structure over there. If I keep everything in a single drive, then the retrieval is very difficult. That drive itself will have thousands of entries. Thousands of file names will be there. How I should find the one single file? So if I arrange them in the hierarchical fashion, then the retrieval will be easy. For that reason, we go with the tree indexes. That too we generally consider for the balanced tree. Fine. So now it is impractical to maintain a entire database in the memory. Hence, B trees are used to index the data in order to provide the faster access. B trees are used for its data retrieval speed, easy of maintenance, and the simplicity. So it forms a tree structure with the root at the top. The index consists of the B tree balanced tree structure based on the values of the indexed column. In this example, the indexed column is a name and B tree is created using all the existing names that are values of the indexed column. The upper blocks of the tree contain the indexed data pointing to the next lower block, thus forming the hierarchical structure. The lower level blocks, also known as the leaf blocks, contains pointers to the rows stored in the table. Advantages. Since the leaf nodes of a B tree are of the same depth, retrieval of any record from anywhere in the index takes approximately the same time. It will improve the performance of a wide range of queries that either searches a value having an exact match or for a value within a specified range. B tree provides a fast and efficient algorithms to insert, update and delete records that maintain the key order. B trees perform well for small as well as the large tables. Their performance does not degrade as the size of the table grows. B trees optimize costly disk access. Next one, hashed indexes. So in case of hashed indexes, what happens? So there will be a hash function will be there. That function is going to is used for calculating the index value. That function is used for calculating the index value. Hashing is used to compute the address of a record by using a hash function on the search index key value. The hashed values map to the same address. Then collision occurs. If there is a collision occurs, there are schemes to resolve these collisions as applied to generate the new address. Choosing a good hash function is critical to the success of the technique. A good action function means, first, a good hash function, irrespective of the number of search keys, gives an average case lookup that is a small constant. Second, the function distributes records uniformly and randomly among the buckets, where a bucket is defined as a unit of one or more records. A worst hash function is one that maps all the keys to the same bucket. Let us take a simple example. In your classes, we have 62 students. So, in my attendance book, each pages will have 25 rows. So now how many pages I need for the storage of your attendance? I need 3 pages over there. That is page number 1, page number 2 and the page number 3. First, suppose the register number is, let me take the register number is 18. In which page it will lie? How will I decide? 18 modulus I will use a simple one. So 18 divided by 25. What the index I will get? 0. That is coefficient is 0 plus 1 will be your attendance name is there in the first page. If my attendance, my register number is 48. 48 divided by 25. How much? I will take only the quotient. How much will I get? 1 plus 1. What is the page number where you are there? In the page number 2. Here. If my attendance, my register number is 61 divided by 25. What is the quotient? It is 2. 2 plus 1, which is 3. That is attendance in the third page. So simple example I have told. So like this, the hash function will be there. So here 25 divided by 25 is my hash function. Divided by 25 is my hash function. That is, we need to select an hash function in such a way that easy for retrieval. I should get my data retrieval should be easier. Second one, there should be less number of collisions. There should be less number of collisions. So in such a way, I need to select my hash function. Suppose for your case, if you are using your names, so then we used to have the modulus of 26 will be there. First, my name is starting from the A. A ASCII A value is 0. 0 mod 26 is 0. That is all the entries for the A are there on the page number 0. If my name starts at the B, B it is 1. 1 mod 26 will be 1. So it is all the B entries will be in the page 1. So like this we can have the hash function. So for the alphabets we can go for the mod 26. If it is numerals we can go for the mod 10. That is we can have the buckets from 0 to 9. Fine. So in such a way we need to design the hash function. So designing the good hash function itself is a good topic. Fine. A good hash function should have the less number of collisions and an average case lookup. In worst fact function maps all my entries to the same bucket. If it mapped to the same bucket, then what is the use of the index? Fine. So that's why we need to, the hash function should be an efficient one. It should generate the index appropriately and there should be less number of collisions should be there. The drawback of using the hashed index is, though the number of buckets is fixed, the number of files may grow with the time. Whether the number of buckets is too large, storage space is wasted. If the number of buckets is too small, then there may be collisions. Next, the operations performed on the hashing are insertion, that is inserting a record, searching for a record and deleting the record. Inserting the record. To insert a record, that is a ki as its search value, use the hash function h of ki to compute the address of the bucket for that record. If the bucket is free, store the record, else go for the chaining or some other mechanism. Linked list. Searching. To search for the record, go with the hash function, compute the address and go to its location. If there are multiple records, then you do your sequential search. Then the deletion. To delete, you first compute the address of the bucket, then go there, search for it. If it there, then you are going to delete the record. The references for this video are from the textbook Ellis Horowitz and Sartaj Sahni, Fundamentals of Data Structures in C, 2nd edition, University Press 2014. And Data Structures from Sham Outline Series, written by Samuel Liptus, revised 1st edition, Tata McGraw-Hill 2014. Thank you.